So here I'm showing you some of the equipment that we're going to use in this experiment. But before I show you how we do the experiment, I want to talk about some housekeeping stuff. So first of all, the way in which we get the theoretical accelerations in this experiment is that we're going to make some free body diagrams for various pieces of the apparatus. We put them together to get a force equation, and then we solve for the acceleration. Now, a lot of students find that a little tricky, so I have put up an optional help video to help you with your pre-lab. So if you're struggling with the pre-lab, with the free body diagrams, with the force equation, any of that, go watch that video. The second thing I'll mention is that I know I'm always harping on you guys to level your track carefully, but this is one experiment where it's actually really important that you do. So you can have a lot of trouble getting good agreement between your values on the first half of the experiment if you haven't leveled your track very carefully. So do that as well as you can. And finally, you're going to need to weigh 3 masses in this experiment. One of them is the cart with all of the added masses stacked on top of it, so you just weigh this all as one chunk. The second thing you want to weigh is this mass hanger, and I know it says 50 grams on here, but you should weigh it and get an experimental value. And then the last thing that you're going to weigh is the system mass, which is everything together. So you take the mass hanger and you just stack it on top of the cart with its added masses, and you weigh everything as one big chunk like this. So that'll be your third mass. The electronic balances are on the side counter beside the sink, and the uncertainty is usually written right on them, but feel free to ask your lab instructor if you're unsure about anything. So now I'm going to show you how to do the experiment itself. Now in this experiment, we're going to measure the acceleration in 2 completely different ways. Now the first way is identical to something that you did in Lab 5, where you had a cart with some added masses and a mass hanger that is attached to the cart via a string. And then you're going to put the string and the mass hanger over a pulley at the end. And then the mass hanger is what accelerates your masses. So that's just like what you did in Lab 5. Now before you get your experimental value using the program, you're first going to calculate theoretically what the acceleration of that cart was supposed to be. You do that by making a free body diagram for both the cart and a second one for the mass hanger. And then you're going to use those to get a force equation and then solve for the acceleration of the cart. So you do that first, then you'd run the trial, like you did in Lab 5, where you release the cart down the track, capture a graph, fit a straight line to your velocity time graph, and get your acceleration from that. And once you've done that, then you'll be able to compare your experimental value to the theoretical value you got using the free body diagrams. So that should be fairly straightforward for you. So in the second trial, we're going to be accelerating the cart in a completely different way. What you'll do now is you want to take the cart and remove the mass hanger entirely. So get rid of the string and the mass hanger. We aren't going to use this at all for the second trial. Also, get rid of the added masses. That's just going to make things less noisy later, so we don't need those. The way in which you're going to accelerate the cart in the second trial is you're going to tilt the track. So you grab your brick and lift up the sensor end, and now the cart is going to accelerate on its own just due to gravity. So again, no mass hanger, no added masses. We're just going to tilt the track and have an empty cart. Now again, we're going to get the theoretical value first, and you do that by making a free body diagram of your cart, and you solve for the acceleration of the cart. One of the things you're going to need to do that calculation, however, is the angle of the track. So you get that using this gizmo here, where you put that on the track, and then you'll be able to read off what the angle of the track is. Now, the percent uncertainties on the angles tend to be a little bit high, so to get a smaller percent uncertainty, it's a good idea to try and make your track a little bit steep. So it doesn't have to be too steep that things get really loud and violent when it crashes into the end of the track, but a little steeper means that your percent uncertainty on the angle will be smaller. So you may want to do that. Once you've got your angle, then you can calculate theoretically what the acceleration of the cart is supposed to be, and then you can get your experimental value. So this is fairly straightforward also. Is you would start your program, place the cart outside the dead zone, and just release it, and let it accelerate down the track under gravity. And once you've captured your graphs on the screen, then you fit a straight line through the velocity time graph and get your acceleration from that, and then you can compare that experimental value to the value you got theoretically using your free body diagram. And again, for this second experiment, no added masses, no mass hanger. It's just gravity accelerating your cart down the track.